Okay, I'm pushing on. 21.5. How do we deal with the old solid of hazardous waste? So first and foremost, e-waste is an issue that most people aren't aware that it is a problem, but it is not just a problem, but a growing problem. E-waste is anything that has to do with electronic waste. So computers, televisions, VCR, stereos, copy machines, cell phones, all fit into that category. The problem with e-waste is there's a lot of toxic and hazardous materials inside of them. PVC and lead and mercury and cadmium, all kinds of things that we don't want to get into our system, and they're very difficult to recycle. The U.S. produces half of the whole world's e-waste, and it only recycles about 10% because it's really challenging to do, and so it's an issue that we need to worry about, and it's an ever-growing issue. So, electronic waste or e-waste, of course, is the fastest growing waste problem in the United States. Most of it we ship to other countries. Most of our e-waste gets shipped to China, for instance. And then it creates hazardous working conditions there. So you can see people actually in China doing work with our e-waste, and there's part of it's a burning process. Can you imagine burning electronics? Not a pleasant thing. So the International Basel Convention was attempting to deal with these things. So it bans transferring hazardous materials from one country to another, especially developing countries to developing countries. Trying to shut down that process shouldn't create problems for other people. By the way, just so you know, the U.S., Afghanistan, and Haiti all are countries that would not sign it. So I don't know what that says exactly. Next, hazardous waste. So hazardous waste is a solid or liquid that is toxic, ignitable, corrosive, or reactive enough to explode or release toxic fumes. That sounds pleasant. So, who makes the most of it? Well, our military makes the vast majority of hazardous waste. Both munitions that are both used and unused, explosives, and other chemicals are what the material makes. Next, the chemical industry. Through the chemical production process, storage and disposal, they make a lot. And then mining's the third highest one of those. And it has heavy metal contamination. So where does hazardous waste come from? Mainly these three places. It comes from other places too, but those are the three big ones. So how do we manage that? Well, again, integrated hazardous waste management. Anytime we can integrate it, that's a good thing. We have a priority system trying to get rid of it. So first of all, let's produce less. Always can produce less. That's the first thing we should do. Second, convert waste to less hazardous waste. Or better yet, non-hazardous substances if possible. After that, lastly, we need to find a place for perpetual storage. Leave it there forever, basically. And how do we do that? And so that is all part of the same kind of idea. By the way, the perpetual choices: landfills, underground injection wells, surface impoundments, or inside salt formations. Okay, so how can we detoxify these heavy metals? Well, there's a couple means to kind of make them less potent. One, physical methods. So sometimes charcoal or resins can be used to precipitate the chemical through, and that helps kind of alleviate the problem. Sometimes chemical methods can be used. Chemical reactions that can convert it into other chemical systems. And then we also have biological methods that help with hazardous waste. And so bioremediation is a good example of that. We actually can take bacteria or enzymes and we can put those in the presence of hazardous waste and they'll eat or tear down them. We're starting to use that more and more with oil spills. And the final remediation is where we actually take that material. Let's say we have a spill in the ground, and we plant plants there that will then absorb and filter out that chemical from the groundwater. And so this is a little picture showing that and some of the different techniques that come along with that in specific areas. Excuse me. That's also in your book, by the way, and so you can take a look at it there. It shows you examples of it with inorganic metal contaminants, with organic contaminants, and with radioactive contaminants, and what things they use for each one of those. Interesting stuff. Now, what else can we do? Well, another way to get rid of the hazardous waste is through incineration. And we're not just talking about normal burning it, we're talking about super high temperatures, 2,000 degrees incinerators, plasma torches. And so we're burning it so hot that it breaks down into its basic components because it's under such tremendous heat. This has some pros and cons. It can create some issues, but and one of those issues is the ash that it makes is uber toxic, typically. And so incineration, and then, of course, I just said plasma torches. This is passing really high electrical currents through a gas, and it creates plasma. And so where it's like mini injected into the sun kind of stuff, that helps solve some of the problems. Now, what are the other ones I talked about? Well, deep well disposal is another way to take care of it. So you just drill really far under the earth, and you inject that stuff way down there below water level and all of that kind of thing, and then cap that stuff off. That's one way to solve the problem. It puts it into place, I guess. I don't know if it solves it, but it gives it a holding location. Surface impoundments, we literally dig ponds and pits on the surface of the earth and store them in these kind of pits. And then you can have secure landfills. Secure landfills are kind of like a sanitary landfill on steroids. So you take the hazardous waste, you put them in drums, you encase them in concrete, you bury them really carefully with monitoring apparatuses and layers and surrounding them and a bunch of other things to ensure that if they leak, it's not a big problem. So what else do you need to know with this? What regulations are out there? Well, there's the RCRA Act. That's the cradle to grave system, and this basically was put in place to keep things in check, so we knew where everything was going, where, how, when, why. So this is a tracking system that we use basically, and then the CER-CLA is also known as the Superfund program, and the Superfund program is a system, and we'll talk about this in class. It's a system. Regulation that set aside monies to help deal with hazardous waste removal, disposal of sites that have issues. And so there's what we call Superfund sites. These are places where there's toxic spills that need cleaned up, and this actually gives the funding for that to happen. And so here's a breakdown of the first one I talked about. So this is our nation's primary law governing the disposal of hazardous waste. It was the first one to come out. Came back out in 1976. And so it addressed the main problems of how we manage this kind of stuff. And so it banned open dumping. It encouraged reduction in recycling. And how to manage safe disposal of wastes around the thing. So it was a good basic piece of legislation. This is the Superfund Act. Oh, no, I'm sorry. Missed a page there. So under this first law, the EPA had to categorize hazardous waste, put it into different categories based on toxicity and a bunch of other things. It had to issue permits that allowed you to make those things in the first place, and then how you were going to dispose of them afterwards. And then it required people to keep track of all that waste as they did it. Love Canal is an example of some of the things that can go awry with these kind of issues, and one of the reasons why the law was passed. So between 1842 and 1953, there's a chemical company called Hooker Chemical, and what they were doing is they were making what they make, and they had these barrels of waste that they basically put and dug and buried in an old-fashioned, unfinished canal excavation, where they dug it out, called Love Canal. So this little track, they threw it all in there and covered it up. And 1953, the canal was filled and sold to the Niagara Falls School District, actually, for $1. That was nice of Hooker Chemical, right? Give the school district some land for $1. Very sweet of them. And so when they did that, the company just inserted a little disclaimer that said they're not liable for any of the waste involved with this transaction. So in 1957, the Hooker Chemical warned the school district not to disrupt the ground. Don't mess with the ground because there's toxic waste involved. So in 1959, in elementary school playing fields and homes were built, and it disrupted this clay cap that they had put over top of the whole thing. And by 1976, residents were complaining of all kinds of things like chemical smells and chemical burns, like people falling on the ground and getting chemical burns. Yeah, nice, huh? And then there was also huge increases in the rates of cancer and birth defects and all kinds of stuff in this area. And so, ooh, that's no good. So, old President Carter got himself involved and declared Love Canal a federal disaster area and gave it funds to help solve the problem. And eventually, the area was completely abandoned by 1980. It is still a controversy to how the chemicals should be cleaned up and who's responsible and who's liable and all kinds of things. And so it sparked a debate that resulted in the Superfund Act that we just talked about, which basically enforces polluters to pay to clean up the waste. And that's this right here. That's the CERCLA. Yeah, the Comprehensive Environmental Response Compensation and Liabilities Act. So basically, polluters pay for cleaning up hazardous waste, right? In addition, it also created tax or chemical and petroleum companies. So there's a tax that all these people just paid into, so the fund had money available for issues. It also established this, which is the NPL, which is this national list of priorities of the worst places in the country, the most toxic ones. These are called Superfund sites. And then they get put on this list in order of how bad they are and whether they need to be cleaned up and which ones can be cleaned up most effectively. And so only about 70% of the cleanup costs have come from the polluters. The other third come from the taxes out there in the world from the other chemical industries. So that's a bit of a problem. And so that imbalance was there. And so Congress actually refused to renew the act in 1996. And now it's basically broken a little bit. The tax isn't taking care of it. So who's flipping the bill now? Good old taxpayers are paying the bill now. So 70% is being cleaned up by the actual people who spill it in most cases, but at least 30% is being paid by taxpayers now because Congress didn't want to put that tax burden on companies that were creating wastes. So, generally speaking, pardon me, where's this stuff happening? Well, 1 in 4 Americans live near a brownfield, and a brownfield is basically an abandoned place that has hazardous waste at it. And so where are those at? Well, you can see where are the Superfund sites in the U.S. There's one right there in Casper, and there's one down there in Cheyenne. The one in Casper is out in Evansville by the old refinery there, and then the one down in Cheyenne is on the Air Force Base. Those are the two closest to us. But you can see there's lots of Superfund sites stretched all over the United States.